Hello and welcome back to Maths with Mitch. Today we're going to be looking at further into our series on algebra and talking about similar terms and expanding brackets. Now in the last video we talked about collecting like terms and what a term was. So last time we talked, as a refresher, we said X, Y, Z, and all the different letters you may use, they can be called variables if they're separate, but then when you bring them together as xy or x over y, they then become terms. So you're looking at different terms in an equation, and then any number on the front is coefficients. So 3x, 4y, negative 3xy. The numbers are all coefficients. Okay, so that's the terminology I'm going to continue to use when we're talking about similar terms. So the key is they're not exactly the same, but they're similar, and you want to talk about what the similarities are. So we did X, Y, Z's last time, so let's talk about A, B's and C's, because you'll see a whole range of different letters used. So let's look at the algebraic expression AB plus AC. Now what we have here is we've got variables. So our variables are A, B, and C. Okay, there's three different letters there, three different variables. But our terms, we've only got two terms there. So we've got terms AB and AC. And our coefficients in both cases are just one. Okay, so we don't need to consider coefficients for this case. We're really going to be talking about terms. So they're different terms. We can see that, but we can also say they are similar because both those two terms are one variable times by a. They're both times by a. So we can say that for that reason they are similar terms. And in this case, because they're both times by a, that means that they've got a common factor, and that's what determines that they are similar. So I said they're both times by a. If they're both times by a, that means they have a common factor. Now, where's this useful, and why is this going to be useful in algebra? So we can look at the concept of taking a common factor out of those equations, and this is a process called factorization. So we said a is a common factor to both terms. And we've just talked about that being true. You can see that both of them times by a. AB and AC, they both have a as a common factor. So in terms of factorization, we can now take a out. So we can take a out and say a times b plus c. Oh, pen's gone haywire. B plus c. And that they are the same algebraic expression as one another, but they've been factorized. And we're going to move on to expanding brackets in a minute, and I'll prove why that works in the opposite direction. But we can remember that algebra follows the same rules as arithmetic. So that can be proved by numbers. So if you were to say a is 2, b is 3, c equals 4, what we're saying here is AB is 2 times 3, and AC is 2 times 4. So that would be 6 plus 8, which is 14. Okay, so remembering that, if you did that in numbers, that would be 14. Now, if we were to write it in this form, so we're now saying 2, we're going to say times by 3 plus 4. Are in there correctly? Yes? And see what that equals. So 3 plus 4, that equals 7. So we're saying 2 times 7 is 14. So we can prove there with numbers that the algebra follows the exact same rules as the arithmetic. So now let's look at another example, but using a coefficient that isn't just 1. So now let's consider, we'll use some different letters again to keep mixing it up and make it exciting for us. So let's say 3pq plus plus 3pr. Okay, so now we have this as an algebraic expression. It looks kind of similar as before, but again, let's just be clear. P, Q, and R are all variables. And this time we've got two different terms. So we've got PQ and PR, which are all terms. So let's do some tests. Are they like terms? No, they're not, because they've got different variables in them. But are they similar terms? Well, we can say yes, because they have P as a common factor. Now in this instance, not only do they have P as a common factor, but they've got 3 in the coefficient also as a common factor. So this time, rather than just thinking of taking P out, we can actually take 3P out as the common factor. So we can now say that 3PQ plus 3PR, we just said 3P is the common factor in the equation. So we take 3P out, and then in the bracket, we're going to think of what's left once we've divided 3P, divided through by 3P and taken it out of the bracket. So we're left with Q plus, and here left with R. So there we are, that's written that as a factorization, again taking 3P out as the common factor. And lastly, I want to do a very similar one here. We can take, if we do 3PQ minus 3PR, let's look at just how that will change. The variables are still the same. PQR, still the same variables. PQ and PR are still the same terms. But now our coefficients are positive 3 here and negative 3. So can we still take 3p, positive 3p out as a factor? Well, the answer is yes. But what difference will that make to us? So if we take 3p out, we need to think about each term and what have you done to it. So if you take it out the front, you're going to be dividing the term by 3. So divide by 3p, what you're left with, you have q. And here, if you divide by a positive 3p, what are you left with? Well, you're left with r, but you also have this negative here. So if you divide through by positive 3, negative 3p divided by positive 3p will leave you with a negative 1. So you're left with a negative r. So you also need to be careful about whether you've got a positive and a negative. Likewise, you could take a negative, you might be taking a negative out as your common factor. So you need to be careful about the positives and negatives which you're going to be using. So now let's look at the second part of this video and look at it in reverse. So what we've just done is factorization of similar terms. Now we're going to be looking at expanding brackets. So this works in the opposite way. So you've already had a factorized equation. So you might say you have an algebraic expression with 3x taken out as your factor, and you have y minus 3z. And you might want to expand that bracket. So there'll be different instances where you want to either factorize or expand brackets when it'll be useful for you to solve the equation for the purposes of what you're doing. Now this time you need to consider that what you're doing is multiplying or dividing through each term by the bracket. So there's different ways you could write this out, however it's going to work for you. I used to like drawing arrows just to make sure I never missed them. So I'll say I'm going to times the 3x term out the front, and I'm going to times it by y, and I'm also going to times it by negative 3z. Remembering that you're carrying that positive or negative with the coefficient. So firstly, if I do 3x times y, we have 3x. Remembering times y, you don't need to write the times, it's implied by being next to it, so 3xy. And then the second operation is 3x times minus 3y. So remembering that what we have here is a positive 3y, and algebra follows the rules of arithmetic. So if you have a positive 3y and a negative 3z and you times them together, you end up with a negative. Positive and negative times together makes a negative. So we have negative 3 times 3 is 9, and xz gives xz. So that's our answer once we've expanded the bracket. So now let's look at another example. What if this time we had a factor out the front which was itself negative? So let's have negative 2y as the factor out the front, and let's put 3x minus 5z. Okay, and you get asked to expand the bracket, or you need to expand the bracket for what you're going to do. So let's follow the same process. We're going to do that times that, and that times that. So firstly, we have negative 2y times a positive 3x. So we're going to have, if you take the coefficients first, you can look at minus 2 times positive 3, which is going to give us a minus 6. And then we've got a y times an x, so we can say x, y. And for the next term, we have a negative 2y times by, and remembering you're carrying the positive or the negative sign, so you got minus 5z. So do the coefficients first, remembering your rules of arithmetic. Negative times negative gives a positive, so minus 2 times minus 5 is positive 10. And then do your variables, so you have y, z. So that gives your answer there, minus 6xy plus 10yz. So that's how you're going to manage it if you have a negative term out the front as a factor. So let's now just do one last example and think about it if you have a fraction out the front as a factor, which you may see sometimes. So you have 1/3 x 3y plus 4z. What I want you to understand is it's the exact same process, so follow the same process each time and you won't go wrong. I've changed the colors around here, but that doesn't make a difference to our process. So this time we have 1/3 x times 3y. So the first thing you could do is stop the pen going haywire. So the first thing you can do is do the coefficients. So we've got a positive 3y and a positive 3. So 1/3 times 3 is 1. We don't need to write the 1 if we have it as a coefficient. Then the terms x times y, so we'll be left with xy. Our next term is, again, 1/3 x times by positive 4z, so we're in positive 1/3 times 4. So remembering, you could think about it as 4 is 4 over 1 times a third, and you could follow your normal process, times the bottom, times the bottom, times the top, times the bottom, and then that gives you 4 over 3. So that gives us positive 4 over 3. And then think about what our term is here. We have an x times a z, so that becomes xz. So that is your answer there once you've expanded the brackets. Okay, thanks for watching everybody. That was looking at what are similar terms, factorising similar terms, and then looking at it in reverse with expanding brackets. And I'm sure we'll come on to more complicated ones as we move forward. So thanks for watching. Please subscribe and let me know in the comments if there's anything you want me to cover.